like fastener libraries, these feature libraries. These things are added in. And sometimes, you know, when you are running your version, usually these are checked off. So you may not see the tool. If that is the case, and you may not see, you know, this library, design library. If that is the case, go under Insert or Tools. And find add-ins. Okay, so add-ins are a bunch of capabilities that are not necessarily invoked, so you need to invoke them. So if you go to add-in, it's a good exercise just to go through and find out what else SolidWorks can do. So from circuit work to CAM, Composer, flow simulation, we have everything. We have all these simulation stuff that comes with SolidWorks, which, you know, I think the SolidWorks itself is like the professional or for businesses is like $20,000-$25,000. And if you want to get all of these, you're well into $150,000. So, yeah. As you see, these are the two that you need for this class, SolidWorks Toolbox Library and SolidWorks Toolbox Utility. So you check these on this end, and also check it on the startup. Because if you don't, the next time you fire it up, again, it wouldn't show the toolbox. So yeah, if you don't see the toolbox, make sure that you do this. Okay, so here's the tools. Where was it? Oh. Okay, toolbox, grooves. Okay, and you have O-ring grooves or retaining ring grooves. So this is a retaining ring grooves. And these features, so I can insert that feature, that groove. So I don't have to make it, and it would have the correct width and the correct depth and the correct fillet for a standard ring to go into. And so here's the groove diameter, groove width, and the radius, and the size, which is not selected. You don't have to know any of this. You just click on this and click on this surface. And it knows what groove would go for that. All right. So for that size of the shaft, it knows that this is the information about the groove. So you say create, and it created that, and done. If you want to move it later on, you just go into the sketch for that and move it, whatever. But for this assignment, you don't need to move it, just leave it there. Well, right now I have two grooves. This was one. There. Okay, so I have a standard groove for a standard ring, and I need to bring in the ring. Okay, the rings are in the library, design library. The toolbox is where everything is, the components. The 3D Content Central is the that user community that has put a unlimited number of components, anything you can think of. A human body, you know, a shuttle, pumps and gears, and everything is there. There's no guarantee that they work, but you know, if you're designing something for your capstone, for example, or you can bring in these components. They're good for display, they're good for presentations, they're actually good for so I'll show you how you can subscribe to that. It's free, and show you some of the components. Not sure I remember my password. I haven't been there for a while. Okay, so you go to Toolbox, and these are different standardizing societies. We either do ANSI inch or ANSI metric. The rest are for European standards. And in this case, let's say ANSI inch. Okay, and I got bearings, bolts, bushings, keys, nuts, O-rings, pins, power transmission, retaining rings, washers, all sorts of things. So I want the retaining rings, and I want external retaining rings. External fits outside, internal fits inside. So, and there are three kinds: the basic, the C-type, and the E-type. So the nice thing about one of the nice things about SolidWorks is that if you're designing standard things like bolts and washers and rings and stuff, you can make it intelligent so that it can snap to what it's meant to make. So you don't need to bring it in and do all those mates with it. It has enough intelligence in it. It's called smart mates. So all you have to do is bring it in and snap it where it needs to go. So it goes in. So I grab this, bring it here, and it automatically sizes it for that shaft and for that groove. And you just release it, and you got it. So the final thing is that I'm going to mate this to that, so it would not be floating. It would not be. Escape. All right, so I would say mate this surface to that surface. So that's your final thing that you need to make, and the test is, we grab this and move it. As you see, it doesn't check for interferences, it goes through, but it's possible to check for those interferences. Once you're done, you can do interference check. So let's see. So move components or rotate components. Is that the one? Okay, so I'm going to just move or rotate something. You can do collision detection, you can do physical dynamics. Physical dynamics, it stops when it hits something. Collision detection, it changes the color so you know it has hit. So here is, and you can have particular parts to that, or you can check the whole thing. So if I put it on collision detection, for example, and move this, it's See, it changes color when it hits. So that's the collision. If I put it on physical dynamics, it just wouldn't go through. Got it. Anyway, we're not going to check that, but it has the capability to check the interferences, collision, and those things. Usually, they're hard to use. Okay, so that's your assignment for your next time. Let me also show you some things else. Okay, so one thing about assembly is that the assembly file by itself cannot create parts. It relies on the part models. So you can't send your assembly model to somebody else that has SolidWorks. They try to open it and it can't find any of the components. So if you want to send an assembly, you have to send all the parts with it. In fact, SolidWorks has a feature called Pack and Go, because a part might have, an assembly might have a lot of tiny small pieces, and you don't want to miss anything. So if you say Pack and Go and give it a folder, it puts all the files that the assembly needs. So it's guaranteed that it's not going to complain when you're opening it. But if you want to communicate your design with other people, actually the SolidWorks models are not the way to do it. You want to do the SolidWorks reader, the e-drawing. So the e-drawing for the assembly doesn't need component parts. It's just one file. It's a small file too. And I think that's the ones that I have on the web too. So it has all the information, no problem opening that and discussing with your friends about your design. All right, let's pick another one. Okay, so here I have a couple of bearing blocks, pillow blocks, and a roller. And I want to show you how you can insert fasteners into your model. So this one, if I look at it from the bottom, this side has a couple of fastener holes. The other one does not. So let's go and find the, add those to this one and then insert the fastener. So let's start with that. Okay. To have the fastener insert routines of SolidWorks are very powerful, but they're also very finicky. So for one thing, they only recognize hole wizard holes. Okay, if you create your holes using extruded cut and stuff like that, it wouldn't recognize that. So these has to be done with And we have counter bore for M5 hex head bolt. So that's the result of the design of those fastener bolts. Okay, so I need to know the distance between the two. So center distance is 56 millimeters. The other thing that the routine in SolidWorks that inserts the fastener is called smart fasteners. The holes for mating parts have to, the distance between the fastener holes must be exactly alike. So if one is just even a fraction of a millimeter off, so the holes do not align, it would not do it. Okay, so we want to make sure that on that plate, the distance between the two is 56, and the distance from here to there, distance from here to there is 10 millimeters. Okay, so let's go and open that other file, which is this one. Okay, so I need to put the hole wizard holes here. Let's make them through holes so they go with bolts and nuts. You can also make it to the threaded holes for machine screws. So I'm just gonna sketch on this, or just say hole wizard. Here's the hole wizard. What I want is a through hole for asymmetric. The type would be screw clearances. The size is M5. And it's through the plate. So that's for the specification. As far as the position, I would have two, one here, and one here. Okay, and then I'm going to go into the sketch of that and make sure that these are properly aligned. So this one is vertical, that's fine. The distance between the two was 56. The distance from here to there was 10. And this distance doesn't matter, depending on where you want to put it. You can line it up with the other one if you want, or find out what that is. So you can use it to there is 16.43 millimeters. I don't know. It's not a good number. Let's just leave it as it is. Okay, so we got that. Now let's go back to the assembly. It didn't complain for some reason. Oh, because I have it inserted. So those holes are not aligned properly now. And if I try to insert the screws there, it says, can't do that. So those need to align. So I need to break up the mate that already exists for this one because it doesn't allow me to align those holes. So let's go to the mates and find out where that one is. See that one? Okay, I need to get rid of that. And that now allows me to slide. So I'm going to make the holes line up. So that, you see that I could have done this one, but if you develop good habits of making sure that things that you're aligning physically make sense, that would be much better. Although it's more convenient to do it here, this makes more sense. So you click on that and click on that. Okay, now they're aligned. You can have to double check also. Make sure that, yep, okay. So once you're done with that, now you can insert fasteners that are compatible with those M5 holes, and the counter bore allows for the head of the fastener to go through. Okay, so we go there. Here I want I can grab those bolts and drop them in, but remember that a bolted joint would not only have a bolt, or it would have washers, you have 1 or 2 washers, one on top, one on the bottom, sometimes 2 on top, some 2 on the bottom, and you have a nut at the end. So for each one of these, it's a lot of work to bring all these pieces in. And then if you decide that, oh, you know, you're going to use a different kind of a washer, you might have to change the entire thing. So this is very time consuming and very annoying. So instead of grabbing things and bringing them in, like that, this is Hayes bolt, like this one, you can grab it, bring it in. It finds the, it should find the size. Sometimes it does, sometimes, see, it has the smart mates, so it clicks on those, but you know, it's a standard size. You have to change the size, you know, the size of it, length of it. So it's a lot of work, and it's really very time consuming to do that. So I would not suggest that, because we have what is called smart mates, and it's very powerful. Okay, so the smart mates are smart fasteners. So you click on this one. So the smart fastener does a few things. It says what kind of a bolt you want to go in there. Just pick, you know, the bolt. Pick the washers that go under the bolt head and under the nut, as many as you want. Pick the kind of nut, and I figure out how long the bolt should be to accommodate all of these. And if you make a change, it automatically does that for you. So it's extremely powerful. Okay, so let's pick the smart fastener. It says, be aware that it takes a little bit more time to process that information. I don't know why, because I never have a problem with it. So you can just say, don't show me again. I understand that it might take 1.5 seconds to do that. Okay, so far as the selection, you can say populate all, and it looks for all the fastener types and inserts. I don't like that. That's too much of an automation. So I like to deal with all the bolt patterns, separate bolt patterns separately. So I'll bring in a little bit of a manualness to it. I like that. I don't want to just push a button and everything happens. Okay, so instead of that, I would select, for example, this one. All right. If you click on it and it shows up in that window, it means that it recognized it. So that's a good sign. It's a counter bore for M5. Okay, and then if I say add, it would only add to that pattern. It doesn't add to the other ones. Okay, you see that? It added to both. It picked a hex bolt that you can change if you want to any kind of bolt you want. And the top stack is what goes underneath the head, and the bottom stack is what goes at the end. So right now, it doesn't have anything. So I can say add a narrow flat washer, or regular flat washer, or wide flat washer to the top. See, they came up a little bit. Now there is a washer underneath it. And the bottom stack, I say add a narrow flat washer, a regular flat washer, whatever you want. Okay, and that goes in the bottom, you see that? Now I'm going to add the nuts, and it recognizes that the bolt needs to be longer to accommodate the nut. So in the bottom stack, I say Higgs nut style 1. Okay, you see that? Added that. Yeah, so it also has some other options that you can allow. And once you say okay, you can go back and change the bolt type, the nut type, the washer types, the number, everything you want. So it's very powerful, and definitely you want to use that. There's something even more powerful than that, and I don't think we need to go into that, but you can design your parts without the fastener holes and add them in the assembly. It's called hole series. Okay, so I think it's under here, hole series. So there, you click where you want the fasteners to be. It goes into the individual parts, cuts those hole visit holes, and then puts it. It's extremely powerful, but it's also extremely sensitive. So I wouldn't go into whole series. It's just relying too much on everything working well. Plus, it makes everything dependent on each other. If one thing you don't want to do, or you want to minimize, is for one part to have features that are dependent on other parts. Okay? Because that becomes a nightmare. So you want to keep them, if you do whole series, it makes your parts depending on the assembly. So you make changes in the assembly, everything gets mixed up in the parts. So keep your parts as much independent of other parts and other files as possible. Okay, well, that's a good start. I guess you have enough information to do your first one at least. And we'll continue on this next
one. Oh, yeah.